Hey visual learners, we are back with a bold new look. You're watching VL Extras. The pace of progress in aviation seemed to hit a brick wall for a while with no outstanding innovations coming from companies like Airbus and Boeing. But today, we're soaring into the future with Natilus, a San Diego startup rewriting aviation's playbook. Their Horizon aircraft, a blended wing-body marvel, promises to carry 200 passengers with 50% less emissions and 30% less fuel than a Boeing 737 or Airbus A320. Led by visionary Aleksey Matyushev, Natilus aims to decarbonize air travel and challenge the industry's giants. But can this radical design take flight by 2030? Let's explore the story of Natilus, its founder, and the Horizon reshaping aviation. Aleksey Matyushev, Natilus's CEO and co-founder, is no stranger to pushing boundaries. With an aerospace engineering degree from Embry-Riddle, he cut his teeth as lead aerodynamicist at Piper Aircraft, shaping the Piper Jet Altair and M600. At Kratos Defense, he led aerodynamics for military UAV systems, mastering stability and control. As a consultant, Aleksey tackled over 25 aircraft programs, from general aviation to drones, excelling in design, computational fluid dynamics, and certification. His expertise set the stage for Natilus, co-founded with Anatoly Starr in 2016 to revolutionize air freight and passenger travel. Aleksey's vision? Use cutting-edge tech to make aviation sustainable, efficient, and accessible, connecting the world like never before.
What are the economics going to be of Nautilus when you're fully operational and fully commercialized?
As a business, we design, build, and sell our airplanes. It's a pretty good business. You can take a look at the Boeing profit margin side. It's about 20% on the commercial side. Some of these airplanes are hundreds of millions of dollars. So 20% against that kind of business is a pretty good business if you can actually get there.
Founded in 2016 by Aleksey Matyushev and Anatoly Starr, Natilus set out to shake up the freight transport industry with a mission to lower air freight costs, reduce food prices, and connect remote regions to global markets. Backed by heavyweights like Draper Associates, Mubadala, and Starburst Ventures, Natilus boasts a team of innovators from General Atomics, Northrop Grumman, and SpaceX, with experience across 25 aircraft programs. Their first creation, the Kona, a blended wing-body cargo plane, secured 400 orders for its 3.8-ton payload and 900 nautical mile range, set for delivery in 2028. But Natilus didn't stop there. Spurred by the aviation industry's net zero 2050 goals and a looming shortage of 40,000 narrow-body aircraft, they unveiled Horizon, a passenger game changer. With sustainable aviation fuel, SAF, making up just 0.53% of jet fuel in 2024, Natilus bets on blended wing body designs to slash emissions. Let's explore how Horizon aims to redefine air travel. The Horizon is Natilus's bold leap into the narrow-body market. Designed to carry 200 passengers on routes like New York to London or Los Angeles to Boston. Unlike the tube and wing designs dominating aviation for a century, Horizon's blended wing body merges wings and fuselage into one lifting surface, cutting drag by 30% and weight by 25%. This means 50% lower emissions and 30% less fuel than a Boeing 737 or Airbus A320, with 40% more interior space for customizable cabins, think video conference pods, and 2x2 family seating. Aleksey Matyushev says Horizon fills a gap left by Boeing and Airbus, who can't meet the demand for 40,000 new aircraft by 2045. But stability was a hurdle until Natilus leveraged NASA X-48 data and CFD tools to nail aerodynamics without complex fly-by-wire systems. Horizon's Mach 0.8 cruise speed and compatibility with existing airports make it a practical disruptor. But can it hit its ambitious 2030 service entry? Let's unpack the challenge.
Air travel is on the verge of a revolution, but the nature of the revolution we're talking about today really depends on who you ask. According to some of aviation's brightest minds, the future of air travel is supersonic or perhaps even hypersonic, chasing the legacy of the Concorde into uncharted skies. Others believe that the future lies on the edge of space, taking advantage of sheer altitude to merely leave the atmosphere entirely before barreling back to Earth. Still others believe that the future of air travel should be its demise, replaced by high-speed rail, hyperloop, or something else entirely. But if there's one path forward for modern aviation that can offer marked improvements across the board while being perfectly technically feasible today, it is the blended wing body, or BWB aircraft. Ultimately known as a hybrid wing body or lifting aerofoil, the blended wing aircraft would be a strange sight if it flew over your home tomorrow, but the advantages that it provides over modern commercial aircraft are simply stunning. So today we're going to take a look at blended wing aircraft, what it is, why it works, what it can offer, and the parallel questions of how it might get into the sky, and who is going to put it there. Blended wing aircraft. And no, it's not the same configuration as, say, America's B-2 Spirit bomber or Germany's World War II-era Horten HO-229. That's a flying wing aircraft. It is a completely different thing. Instead, to get the simplest mental image of this machine that's meant to fly in the sky, we're going to picture something that lives in the water. The ocean's sunfish. We'll pop a picture up on screen, but we know a lot of you just listen to this, so basically those are those great big fish with the up and down wings known for sunning themselves on the water's surface as if they're dead and then scaring the daylights out of motorboat owners who don't know what they're looking at. To picture a blended wing aircraft, we'll ask you to mentally make a few adjustments to that sunfish form. Slope its top and bottom fins behind it at an angle, make those fins a good deal longer so they can stretch back behind it, and then picture our dear sunfish friend hurtling through the sky at 30,000 feet. Not a pretty picture, but swap out our flying fish for any of the prominent concept designs for a modern blended wing body aircraft, and you'll very quickly see how we got here. Now, the blended wing body aircraft, or BWB, as we're going to refer to it for the duration of this episode because it's easier, utilizes a wide body rather than the cylindrical long fuselages that you'd see on your average commercial jetliner. Its wings are long and often quite narrow relative to what you'd expect on an aircraft of this sheer bulkiness. The cockpit will be set forward on a stubby nose. The engines will be set somewhere at or towards the very back of the plane, and it may or may not have a tail based on who's designing it and what they'd like it to be able to do. Visually, they aren't quite unaerodynamic. There are certain design elements on these aircraft and in concept art pieces that indicate that they are indeed a thing that flies. But they're not the sort of aircraft where it's visibly intuitive to understand how they fly. So, well, here are the basics for you. The big thing that a BWB aircraft design achieves, aerodynamically speaking, is to substantially reduce what's called the wetted area of the plane. That is the surface area of an aircraft that directly interacts with airflow during flight. So the fuselage, the wings, the engines, and anything else of that sort that sticks out of the aircraft. It's not just the frontal area. After all, airflow skims against, say, the long pencil-like fuselage of a modern commercial jet, as well as peeling past the nose. For standard commercial aircraft, the way that they're built is pretty good at keeping them in the sky, but with the drawback that the wetted area is pretty substantial. And while a blended body aircraft does have a substantial wetted area of its own, it offers a much better trade-off between the amount of wetted area and the amount of internal aircraft that you get for every wetted square meter. Alongside the reductions in wetted area, a BWB aircraft will thus experience reduced drag, flying through the air easier with less of a need to expend fuel. Aircraft with a wider body, even though they look like they're less aerodynamic, actually generate a good deal more lift on its underbelly, meaning that you need less wing, which in turn reduces the wetted area that you're dealing with even further. And although the BWB aircraft design has never been adapted into a commercial jetliner, at least not yet, it is a proven concept. During the Cold War, both the Soviets and the Americans built BWB aircraft to serve as bombers, the Soviet Tupolev Tu-160 and the American Rockwell B-1 Lancer. Both aircraft featured a less egregiously disproportionate body relative to its wings than the designs floating around today, but they were BWB aircraft nonetheless. Also on the list are two other American designs from the Cold War era, the Lockheed SR-71 Blackbird and its companion design, the Lockheed A-12 or YF-12. The US even flies a BWB-style drone in service today, the Northrop Grumman Bat, with a handful of copies known to be in use around the world. BWB-style aircraft prototypes have been around since the 1940s, starting with the propeller-driven McDonnell Douglas XP-67, the Moonbat, during World War II, and the UK's even earlier prototype, the Westland Dreadnought, flown exactly one time all the way back in 1924. Airbus has a technology demonstrator called the Maverick based on a BWB design, while America's latest flying prototype, the one that looks most like a design that could feasibly turn into a passenger aircraft, was retired in 2017 after a battery of flight tests that saw it labeled, quote, a huge success. It was dubbed the X-48 and built by Boeing on behalf of NASA. Alright, so that's the brief history of the BWB aircraft design, but just as important is asking why this design has been drawn on so many times before. And the key answers come in two areas: payload and efficiency. Because of its aerodynamic advantages, increasing lift while reducing drag, a BWB-style plane can carry far more inside its bulky fuselage than the average standard-looking aircraft of today. Basically, you get a lot more airplane to work with in exchange for less wetted area, something that would become paradoxical if we were talking about your typical passenger plane, but becomes much more straightforward once we adopt a substantially wider fuselage. Meanwhile, less drag on the aircraft means that there's substantially less power required at any given moment to keep it airborne despite its heavier payload. According to the US Air Force, currently engaged in BWB work for reasons that we're just about to discuss, a BWB aircraft increases aerodynamic efficiency by, quote, at least 30% over the bulky standard design aircraft that the Air Force is considering replacing. BWBs are also a good bit quieter, according to a range of findings from various prototypes and operational models. No matter what you're looking to fly, be it military equipment, freight, or people, the combination of more inside room, better fuel efficiency, and a quieter aircraft is good for everybody, so it should be no surprise that around the world, efforts to design such an aircraft are underway. Now, the first BWB jet proposal worth discussing comes to us from the same place as so many innovative aircraft over the years: the United States military, particularly in this case, the Air Force. The USAF has been partnered with a Long Beach, California-based startup aviation company called Jet Zero since August 2023. Jet Zero is well on its way to building a prototype BWB aircraft for the Air Force, a technology demonstrator that seizes on the early progress of that NASA prototype that we mentioned before, the X-48, and seeks to bring its capabilities to a new level. As of now, in early 2025, the plan is to assemble and begin flight testing on a prototype aircraft by or before the year 2027. The upcoming prototype won't be built by Jet Zero, but by a far more established and trusted name in the aerospace defense world, Northrop Grumman. The Defense Corporation's Scaled Composites division will build the aircraft with the hope of successfully upscaling the flight control findings that Jet Zero has already generated. The full-size aircraft is already in the process of having its parts manufactured, with assembly expected to be completed.
Horizon's promise is thrilling, but the road to 2030 is steep. Blended wing bodies, pioneered by McDonnell Douglas in the 1990s, struggled with stability and control. Natilus solved this through 3 wind tunnel tests, achieving stability without costly fly-by-wire per Aleksey Matyushev. Yet building a full-scale BWB is uncharted territory. Only wind tunnel data and prototypes exist. Certification by 2030, just 6 years from design, is ambitious, especially with Natilus's lean team of 50 engineers compared to Boeing's thousands. Funding is another hurdle. Billions are needed, though investors like VU Venture Partners are on board. Passenger concerns like emergency evacuations in wider cabins loom, but Horizon's 2-level design adds exits. Meanwhile, competitors like Jet Zero aim for 2030, and Airbus's Zero eyes hydrogen power. Natilus's Horizon is more than an aircraft. It's a vision for sustainable aviation.
Have you ever wondered what the interior of a passenger-ready, blended wing body, or BWB aircraft would look like? Well, wonder no more, as today a San Diego-based company called Natilus released details and images showing the layout, seats, and comfort features of what promises to be a revolutionary design in the aviation industry. But first, a thing or two about what a blended wing body aircraft is all about. That would be a plane that shows no clear distinction between its main fuselage and wings, although it has them both. It's a choice that in theory should deliver several advantages over traditional aircraft frames. For one, such a plane would be capable of generating more lift and would face less drag as it moves through the air. When it comes to interior space, because it's not a small tube with wings to its sides, it should deliver a lot more interior space for people to enjoy. It's unclear exactly why blended wing body machines are not flying in the skies of our world yet. God knows there have been several attempts at making them real. Back in the 1920s, the Westland Dreadnought came about, followed in the 1990s by the BWB-17 of McDonnell Douglas and NASA. At some point, even Airbus and Bombardier gave the idea a try, but nothing really came of it. As you're watching this, there are at least 2 companies gunning to make blended wing-body aircraft a reality of our time. Jet Zero is one of them, whose Z4 is expected to fly for the first time as a demonstrator later this decade. The second, and the focus of our here story, is Natilus, who is working on a potentially game-changing flyer called the Horizon. This plane has been the focus of our stories before, but we're coming back to it after the company gave us a glimpse at the thing's interior. Remember how I said a BWB design facilitates greater interior space? Watch on and find out exactly what that means. First up, it's worth mentioning that the interior of the Horizon will be customizable, meaning it could be adapted to serve whatever plans airlines have for it. There are a couple of standard layouts though, and it is them that have been detailed. At its maximum capacity, the Horizon will be capable of carrying 196 passengers. 40 of them will be seated in first-class seats at 38-inch pitch, 48 in economy plus seats at 34-inch pitch, and 108 in economy seats at 31-inch pitch. Natilus says the seats are 20-inch wide, and they offer a huge 7.5 feet of headroom. In lie-down position, they extend to 78 inches. This layout is also equipped with 8 exit doors. It's unclear how they solve the issue of evacuating passengers in case of an emergency in such a design, and up to 4 restrooms. A more premium configuration would allow only 164 passengers to climb on board, 16 lay-down first-class seats, 16 business-class seats, 60 economy plus seats, and 72 economy seats. Each Horizon aircraft can be configured to include 3 video conference pods, each of them fully equipped with hardware and connections that allow for both video and audio calls to be made. If need be, a so-called club seating will be introduced, allowing families, colleagues, and friends to stay close to one another during long flights. Even if they are generally bad in today's airplanes, the economy seats in this plane will each be equipped with 15-inch back-of-seat infotainment systems to get passengers' minds off things. There will be an intelligent lighting system on board that can be customized to mimic natural or ambient light, and can even be synced with the infotainment system. The plane will be powered by a pair of yet undisclosed engines, mounted on top of the fuselage. This position will make them low noise, and they'll be able to push the Horizon forward for distances of up to 4,000 miles while carrying a payload of up to 25 tons. Supposedly, the engines will eat up 25% less fuel than comparable tube-in-wing aircraft. That translates into 50% less money needed to operate the plane, according to the company working on it. The Horizon is being designed in such a way that it will be capable of using existing airport infrastructure. It is intended to compete with the Boeing 737 MAX and Airbus A320. Natilus calls it the Boeing killer. The plan is to have the Horizon in the air as soon as early next decade. Natilus has even begun looking for a site where to build the assembly facility. Prime candidates are the US, UAE, India, and Saudi Arabia. Initial details say the place will cover 2.5 million square feet and it will employ some 3,000 people.
Natilus's BWB could redefine air travel, from work from sky pods to family-friendly cabins. Like, comment your thoughts on blended wing aircraft and subscribe for more tech breakthroughs. In aviation, the future is green. Let's fly smarter.
Lying with a war, teeth sinking deeper, hunger begging for more. Hands up, let it drop.